Hi children. So in that module 1 already we discussed the 6 concepts, no? So the next concept, 7th concept, that is logarithms. Okay, so logarithms, before we discussed about that exponents, and after that surds also we discussed, right? So here depends on that exponents, we are going to learn about that logarithms. Okay, so first before going to discuss about that how to define that logarithms, we will discuss. Okay, see here. What about that logarithms? So here logarithms always define for that positive real numbers only. Always define for that positive real numbers. So what is the definition of that logarithms? Okay. For example here, if a comma b are any two positive real numbers, children, already we know that real numbers means in the first concept number system we discussed about that real numbers, right? So here the combination of natural numbers, whole numbers, integers, rational numbers, irrational numbers, everything there in that real numbers, we know that. So here logarithms define for that only positive real numbers. So that's why here I am going to take that if a comma b are any two positive real numbers and here a not equals to 1. Okay. A and B are any two positive real numbers, but here the condition is A not equals to 1. Okay, such that here X is a real number. X is a real number such that A power X is equals to B. Okay, once see that definition of that logarithm. If a comma b are any positive real numbers, a not equals to 1, x is a real number such that a power x is equals to b. Then x is called logarithm of b to the base a. Okay, so don't be confused that once again I will tell you that, listen, if a comma b are any two positive real numbers, here a is not equals to 1. I will tell you that why here a is not equals to 1, I will tell you the reason. And here x is a real number, okay, such that here a power x is equals to b. Children, by observing this one we can say that here a power x exponential form is there. So before starting that logarithms I told you that depends on that exponents only, we will discuss about that logarithms I said. Okay, so here first only we can observe that this is exponential form, right? So here a power x is equals to b. Then here x is called logarithm of b to the base a. Okay, so that is called that definition of logarithm. Okay, so it is denoted by, actually we written in that sentence form, right? So how to write in that symbolic form? So it is denoted by, actually we taken here a power x is equals to b. Okay, just we have to transpose that. When you are going to apply that logarithm to that exponential form, just you have to transform these two values. Okay, just we have to change that x and b places. Okay, the value which is there at the place of x and the value which is there at the place of b, just we have to change those two values. Then we can apply that logarithm. Okay, so how we can write this means log of, just I am applying log to this one. So here actually we have a power x. So write a as it is. A as it is. Just at the place of x we have to write that b. Okay, which is equals to x. Okay ma. So here log b to the base a is equal to x. How we can read this one? Actually this one we have to write it as log b to the base a is equal to x. Understood? Now once again I will tell you the definition by using this one. See here. Here a and b are any two positive real numbers and x is also a real number, and here a not equals to 1, that is the condition. So here x such that x is called here Actually x we can write in the form of a power x is equals to b. So here x is called the logarithm of b, log of b to the base a. X is called log b to the base a. Okay, so this is called the definition of logarithm. Understood my everyone? Yes, see here. So this is the definition of logarithm. So here logarithm, actually we can write this one as a log. Okay, this is the short form of that logarithm. Okay, so this one we can abbreviate this one as a logarithm. Logarithm, simply we can write it as a log. Okay, so this is the short form of logarithm. Okay, actually here we have the types of logarithms. Okay, we will discuss that later, types of, just normally I will tell you that what are the names of that logarithms. The first one is the common logarithm. What is that? Common logarithm. Common logarithm. The second one is natural logarithm. Okay, and the third one is the compound logarithm. Okay, just we will know about that, the names of that logarithms. In that next class we will discuss about that common logarithms, natural logarithms and compound logarithms. Actually here these all are that names of that logarithms. Okay, we will discuss briefly about in that next class. Okay. So here common logarithms, what about that common logarithms means, here base should be 10. Okay, base of that log is 10. Actually here we written that log b to the base a is equal to x, no. So here at the place of a, if we have that 10, then we will call that one as common logarithms. Okay, and here natural logarithms means at the place of a we will have that e. So we can write this one as log b some base e. Okay, such type of logarithms are called here natural logarithms. Okay, in that common logarithms generally we can say that for base is always equals to 10, and for that natural logarithms base is always equals to e. Okay, and here compound logarithms means here the base is not equals to 10 and not equals to e, other than 10 or e, other than 10 or e. The leftover any other number will come at the place of a, then we will call that logarithms as compound logarithms. Did you understand, ma'am? Okay, see here. Once again I will tell you that common logarithm means common logarithm is defined for that base 10. And here natural logarithm means that is base is defined for e. And here compound logarithms means here base is that is not equals to 10 or not equals to e, which means other than 10 or e. So here at the place of a we can take that 2, 3, so and so, any base here. Okay, just like that log 5 to the base 2. Log 5 to the base 2. So such type of logarithms are called here compound logarithms. Why? Because here base is not equals to 10 and base is not equals to e. Okay, here base is equals to 2. So such type of logarithms are known as compound logarithms. Okay, ma? See. So children, up to now we discussed about that what is the definition of a logarithm. Okay, but before going to that, I told you that what here, actually we will discuss about that exponential form, later we will discuss about that logarithm I said. Okay, why? Because you are saying exponential form, ma'am, here. So what is the relation between exponential form and logarithm form? See here, for example, 2 square is equals to, we know that 2 square is equals to 4. Okay, or else by using that values already we written a power x is equals to some n or some b. Okay, while you are applying that logarithm form, actually this is exponential form. By converting it into logarithm form, what we will get here? Log of a, actually base is a, at the place of x what we have to write? N we have to write, at the place of n we have to write that x. Okay, so how we will read this? Log n to the base a is equal to x. Understood, ma? So every exponential form we can convert into that logarithmic form here. Okay, so how to convert that exponential forms into logarithm form? By using that real numbers, so positive real numbers, I will tell you here, see that. So here generally we know that 2 square is equals to 4. Okay, 2 square means which is nothing but equals to 2 multiplied itself by 2 times. So its value is equals to 4, we know that. So by applying that log, how it will be changed means log, actually 2 is there means base exactly what is there here, exactly we have to write this one. Okay, just we have to change the 2 and 4 only, no? The places of 2 and 4 only we have to change. So at the place of 2, 4 we have to write, and at the place of 4 we have to write the 2. Understood, ma? So here this is the logarithm form. Why? Because how it will be possible, ma'am, means here actually we have that sum laws. Okay, so briefly we will discuss about that laws in that later class. Just I will tell you here how we will got that log 4 to the base 2 is equals to 2. What is the proof? How you are saying? Maybe you may have that doubt. Okay, so here just I will tell you that what is the law we used here, that is log a power m to the base b is equals to m log a base b. Okay, this law we used. Before going to this one, we have to use another law also. Okay, that is log a to the base a is equals to always 1. Log a to the base a is equals to 1 I am saying here. What is the proof? I will tell you that. So just see here, first we will discuss about this one, later we will discuss about this one. Okay, just see here. Actually we know that 2 square is equals to, or 2 power 1 is equals to, we know that 2 power 1 is equals to 2. Yes or no? The value of 2 power 1 is equals to 2. By applying that logarithm, what we will get here? Log of, just we have to change these two values, no? So just we have to transpose these two values. So 1 become as 2 here, and base exactly what is there, we have to write that, which is equals to 1. Understood? So log 2 base 2 is equals to 1. Am I clear? So just see here, this actually here also a is there, here also a is there. A is nothing but same some real number, positive real number. So positive real number I taken here 2. So a and a both are same, and here also 2 and 2 both are same. Now here this is in the same form or not? Okay, or else one more example I will tell you that. By taking that a only I will tell, see here. A power 1 is equals to a. For any number, if its power is 1, then always its value equals to the number itself. We know that, right? 100 power 1 is equals to 100, 1000 power 1 is equals to 1000, 10,000 power 1 is equals to 10,000, whatever it may be, any largest number or the smallest number. Okay, if its power is equals to 1, then the value of that total equation or total expression is equals to the same number itself, we know that. Okay. So here say that a power 1 is equals to a. So by applying that log, again change these two values here. Okay. So at the place of 1 we will get it as a, and here base a, which is equals to 1. So we are getting here this law. Understood, ma? So by applying this law only we can understand about this one. Okay. So did you, I think you understood this one. Okay. So see here. Like this only, some other examples I will tell you that, see here, and we know that 3 power 1 is equals to 3. We know that, right? So by applying that log, how we can write? Just we have to transpose these two. So 3 and here base 3, which is equals to 1. Log a to the base a is equals to 1. I am going to tell you one more example. 4 power 1 is equals to 4. 5 power 1 is equals to 5. 6 power 1 is equals to 6. Already I told you, right? So here by applying that log, what you will get? Log 4 to the base 4 is equals to 1. Okay. And here log 5 to the base 5, which is equals to 1. And in the same way, log 6 to the base 6, which is equals to 1. So like that only, log a to the base a is always equals to 1. So log 6 to the base 6, what is the value here? Log 6 base 6, both also same only. So without saying, we can say that its value is equals to 1. Understood? So like that only. Log 25 to the base 25. What is the value here? Why? Again 1 only. Why? Because here those two values are same. B value and A value, those two are so same here, no? So that's why log a base a, that is in the form of log a to the base a, so which is equals to 1. Understood ma? This is also one of the law. So by applying this one and these two laws, we can define this one. Okay, how to define this one? See here. So what is the first formula? I told you that here we have to use log a power m base b is equals to m log a base b. This one I will tell you that later, this law proof. Okay, in that next class I will tell you that all the laws of that logarithms and its proofs also I will tell you that. In that meanwhile I will explain you this one. Okay, so what is that another law here we have to use? That is log a to the base a is equals to 1. Okay, how to use that one, ma'am? See here. Log 4 base 2 which is equals to 2 I am saying, right? So we have to prove this one. So actually this is LHS and this is RHS. So first I am going to take that LHS value here. So this one we can write it as log 4, we can write it as 2 square. Am I correct here? 4 shall we write 2 square here? Yes. So 2 square and here base is 2. Okay ma. Now this is in the form of log a base b and here a power m value is there. This is in the form of a power m. Yes or no? Here 2 square a power m. Those also same, right? So here we can write this one as m will come forward. So m will come forward means here 2 is there. So 2 and the leftover here a is there. So here a is 2. So write here 2 and here this is b. So b is also equals to 2. B is nothing but here base only, no? So 2 log 2 base 2. Okay, understand ma? So here already we know that log a base a value is always equals to 1. So here 2 into log 2 base 2 value always equals to 1, we know that. So 2 into 1 value is equals to 2. Understand? So here we got that RHS. Actually we taken LHS as log 4 to the base 2 and here RHS is 2. So we got that RHS as 2. So by observing this one, LHS is equals to RHS. Understand ma how to convert that exponential form into logarithm form? Okay, so I'll tell you that logarithm form how to convert into exponential form now. Log 6, okay, log 6 to the base 2 which is equals to here some x. Log 6 to the base 2 is equal to some x they given. So just convert this one into that exponential form. So simply here previous we changed these two, no? So like that only again changed these two values. So 2 power x is equals to 6 here. If it will be existed then the value of x is something you will get. Okay, I'll tell you one more example, see that. Log 4 base 2 which is equals to 2. Already we defined this one, right? So how to convert this one? Just I am telling you here, we have to change always. If you convert that logarithm form into exponential form or exponential form into logarithm form, always you have to keep one thing in your brain. That is just you have to convert these two values. Just you have to change the places of these two values only. Okay, no need to change the base value. We should not touch that base value here. Okay, so keep that base value like that. Just we have to change the values of here 6 and x. In these two places what values are there, just we have to transpose those two values. Okay, so see here 4 and 2. So here we are converting into exponential form, no? So while you are converting into exponential form, we should not write that logarithm. Okay, so 2 square is equals to 4. So this is that exponential form. This is that exponential form. Did you understand that? Okay, so this is that exponential form and this is that logarithmic form. Understand ma? So just observe that exponential form value, is it correct or not? Exponential form easily we can say that that is correct or not. Why? Because here 2 square is there. 2 square means 2 is multiplied itself by 2 times. So what is the value of 2 multiplied itself by 2 times? 4 only, no, we will get. So 2 square is equals to 4. Okay, so while you are converting into logarithmic form, again we are getting here log 4 to the base 2 is equals to 2. This proof also I told you, no? Okay, so like this only I will give here some examples. If you have an idea then you can change that, or if you are not getting that answers, just follow my class, then I will tell you that. Okay, is it correct or not? Just you have to check it. Okay, first I will write that all the questions before completion of my questions, just you try that. Okay, here these values are correct or not. Okay, have you tried these three? If anyone got that answer, just comment in that comment section. Okay children, I'll tell you that answers. If you didn't get that answer, then follow my class. If you are trying, then just pause my class and try that. Let us check your answer, it is correct or not. Okay, so by converting into exponential form, we can say that that is correct or not. Okay, so here log 16 to the base 2, which is equals to 4 I am giving, right? So convert that one into exponential form here. Convert into exponential form. What you will get? At the place of 16, what we have to write? Yes, 4 we have to write. So 2 power 4, which is equals to 16. Am I correct? What is the value of 2 power 4? 2 power 4 means we have to multiply the same number itself by 4 times. Then what you will get here? 2 2s are 4, 4 2s 8, 8 2 16. So we are getting here 16 or not? Yes, we got that 2 power 4 is equal to 16. Understood? So it is correct or not? Yes, it is true. And here it is. Log 27 base 3 is equals to 3. Again convert into that exponential form. So what you will get? Base as it is we have to write. At the place of 27, what is the number we have to write? Yes, good. That is 3. And here, which is equals to, at the place of 3, we have to write that 27. So 3 cube. 3 cube means 3 multiplied itself by how many times? 3 times. So 3 3 is 9, 9 3 is 27. So this is also correct statement only. Next, here it is. Again the base is 5. At the place of 125, what is the number we have to write? 3. So 5 cube is equals to 125. 5 5 is 25, 25 5 is 125. Am I clear? Okay, so this is the way to convert that logarithmic form into exponential form, and before we discuss that exponential form into logarithm form also. So children, I told you that at starting definition I told you that a not equals to 1. A and b are any two real numbers, and here a not equals to 1 I said. What is the reason? I'll tell you, see here. For example, 1 square is equals to 1. Am I clear? 1 square is equals to 1. Yes or no? 1 cube is equals to 1. Yes. 1 power 4 is equals to 1. Yes or no? And here 1 power 5 is equals to 1. Yes or no? Yes. Why? Because 1 power any number, if here 1 is a positive, logarithmic functions define for that positive real numbers only. Already we know that. So here I am going to take that one as a 1 square. 1 power 1 is always 1. 1 square is always 1. 1 multiplied itself by number of times. 1 multiplied itself by number of times. Then again we will get its answer as always positive 1. Okay. So that's why we written like this exponential form. Just convert into that logarithmic form. What you will get here? Log of, just we have to change these two values only, no? Okay. So just transpose these two values here. At the place of 2, just write that 1. And here we are having 1. And at the place of 1, just write that 2. Is it possible? Is it possible or not? Yes, it is not possible. Why? Because already we know the condition, that is log a, the logarithmic form which is in the form of log a to the base a is always equals to 1. Already we defined that, right? But here we are getting log 1 to the base 1 is equals to 2. Is it possible here? Already we know that proof also here. Then how we can say that log 1 to the base 1 is equals to 2? Okay. Okay, here it will be some log 1 to the base 1 is equals to 2. Just go for that another. Here what you will get? Log at the place of 3, just we have to write that 1 and the base also 1, which is equals to 3. So log 1 to the base 1 is equals to, here we are getting that 3. And here we will get it as log 1 to the base 1 is equals to 4. And here we will get that log 1 to the base 1 is equals to 5. So children, just observe that here log 1 to the base 1, log 1 to the base 1, here also log 1 to the base 1, and here also log 1 to the base 1. So there is no change in that LHS function, right? In that LHS value logarithmic function, there is no change. Always we are having log 1 base 1, log 1 base 1. So like that only there in that LHS value. Just observe that RHS value. So here this is 2, 3, 4, 5. How it will be possible? Is it possible here? Here you will get that so many values here for the same function. Okay, so that's why here this is not possible. That's why we are saying that A is not equals to 1. Did you understand the condition? Why? Because already we know that log A to the base A is equals to 1. Already we know that. Okay, and by applying here also we can say that if you will take that log A at the base only we are saying not equals to 1, right? So log A to the base 1 which is equals to 1. Just I am taking that A is equals to 1. If A is equals to 1, then it will be possible or not. Then while converting into that exponential form, 1 power 1 is equals to A. How it will be possible? 1 power 1 is equals to A. Is it possible? Or let's change here some log 25 to the base 1 is equals to 1. Okay, just convert into exponential form. 1 power 1 is equals to 25. Did you agree with this one? 1 power 1 is always 1 only, not equals to any other number, right? So that's why here A always not equals to 1. That is the reason. Okay children, in this video what we discussed about that the definition of that logarithm and what is the short form of that logarithm, and logarithm is defined for that only positive real numbers, and here we learn about that how to convert that logarithmic form into exponential form and exponential form into logarithmic form. So children, in this video I used that two laws. Already for that one law I given that explanation here. In that next video I'll give that explanation for that remaining all laws of logarithms. Okay, thank you.